This is the second part of outcome 3 and it only involves one question, but it's the biggest question in the whole NAB and it's worth 8 marks. You need to get this right, or some of it right, or you'll fail outcome 3. And it's also a question that comes up in lots of past paper questions, so it's worth being able to do this to get a lot of marks. A curve is equation y equals a third x cubed take away 4x squared plus 12x take away 3. Find the stationary points in the curve and using differentiation determine their nature, whether they're maximum or minimums or points of inflection. Okay, so first thing we want to do here is we want to differentiate this function. So rules of differentiation, differentiate each different part, multiply down by the power and reduce it by 1. So known to differentiate gets you a mark for writing dy by dx. Multiply down by 3, which makes 1, so and reduce that by 1, that will make x squared. Multiply down by the 2 and reduce by 1, so we'll take away 8x, and differentiate this and it goes to 12. And then the negative 3 equals to 0, so we don't put that in. So we've got 2 marks already just for differentiating this function. Now for stationary points, the derivative equals 0, it occurs when the gradient's equal to 0. So make sure you write that statement for another mark. So we've got 3 marks already for not doing very much, differentiating this and making a statement that stationary points occur when the derivative is equal to 0. Okay, so moving on, we let this equal to 0. We just said to find the stationary points you let the derivative equal 0, and this is the derivative. So let that equal 0 and try and solve it to find your x values for your stationary points. To do that we factorise, so double brackets, x at the front, and then we have to think what times what multiplies to make 12, but we also need to get a negative 8x. So you can think 3 times 4 makes 12, but you can't get an 8 with that. 12 times 1, you can't get an 8 with that, but 6 times 2, you can make an 8 with 6 and 2. So you're thinking 6 and 2, the signs have to be negative because negative 6x and negative 2x will give you the negative 8, and also negative and negative multiply to make the positive 12 at the back. At this point we think either this bracket has to come to 0 or this bracket has to come to 0 to make it all turn to 0. So to make this first bracket 0, x needs to be 6, and to make the second bracket 0, x would need to be 2. So that's found our x coordinates for the stationary points, but we also need to find the y coordinates. That will get us 1 mark to do this. To get the y values you'll get a second mark, and to get y values you put these values back into the original function. So we substitute 6 in here to get the first y value, and 2 in here in all the places to get the second y value. I'm going to start with 6. So we're going to do y equals a third 6 cubed take away 4 times 6 squared plus 12 times 6 take away 3. You are allowed a calculator for the NAB, so it makes it a bit easier. So this first bit, cube 6 and third, and it comes to 72. Square 6 to get 36 and times by 4, so let's take away 144. Times 6 by 12 and you get plus 72, and then subtract 3. And that comes to negative 3. So that's your first y value worked out. X equals 2. Same idea. We're going to place 2 here, here, and here into the y equals part to get the y value. Don't substitute it into here. That gets the gradient at that point. We just want the y values. So y equals a third of 2 cubed, take away 4 times 2 squared, plus 12 times 2, take away 3. The difference here, we're going to create a fraction here which makes it a wee bit trickier. 2 cubed is 8 times a third is 8 over 3. 2 squared is 4, 2 squared is 4 times 4, that's going to be take away 16. 12 times 2 is 24, and then take away 3. The easiest way I think to do this is to do 24 and then add on this to 24. So that really comes to 2 and 2/3. 3 2s are 6 and then 2 remainders. So that's 2 and 2/3. So that and that comes to 26 and 2/3. And then if you're subtracting 16 and 3, that's the same as subtracting 19. So 26 and 2/3 from these two, subtract 19. So then if we just do the 26, take away the 19, we get 7 and 2/3. So we've worked out our stationary points. They occur at 2, 7 and 2/3, and 6, -3. We now have to determine their nature. So the y values will get you a mark. Doing the two nature tables, you can do one big one, that's absolutely fine. I'm just doing two separate ones here. If you do both of them correctly, we'll get a mark for this. So the first stationary point occurs when x is 2, and the second one occurs when x is 6. So look a wee bit before 2 at 1, a wee bit after 2 at 3, a wee bit before 6 at 5, and a wee bit after 6 at 7. So what we're doing here, we're substituting these values into the derivative to find the gradient, because the derivative is a gradient. So at the station point, the gradient is 0 at both values there. If we substitute 1 into the derivative, we have to work out if it comes out as positive or negative. So let's put 1 back into the derivative and see what happens. Here's the derivative, so if we put 1 in there, you're going to get 1 take away 8 plus 12. 1 take away 8 plus 12 is positive. Next value we're going to put in is 3. So if you think about 3 in here, we're going to have 3 squared, which is 9. If you add 12 to 9, you're going to get 21. And take away 24, 3 8s are 24, that's going to be negative. Now you can do working at the side here, I'm just doing it, showing you quickly. So positive slope is going up the way, flat for 0 gradient, and then negative slope going down the way. So we have a maximum turning point at 2, 7, 2/3. That's the mark. Final mark, we'll do the nature table here and work out if it's a maximum or minimum. So same idea, we substitute these values into the derivative to see if they're positive or negative. So if we put 5 up here into the derivative, we get 5 squared is 25. If you add on 12, you get 37, and 5 8s are 40, so 37 take away 40, that's negative. So down, 0, that's flat, and we have to put 7 into the derivative now. So if we put 7 up here, 7 squared is 49. If you add 12, you get to 61. And if you take away 7 8s are 56. So 61 take away 56, that's positive. So that's going up. So a minimum turning point at 6, -3 for our final mark. So we quick look at this again. To get all 8 marks, differentiate first. That gives you 2 marks. Make your statement for a third mark. Find your x values by letting the derivative equal 0 and solving to get a mark. Find your y values by substituting your x values back into y equals. That's you at 5 marks. Do your nature tables for a mark, and then work out if your maximum and minimum turning points for your final 2 marks.